not hard, to be honest. Okay. A ladder 25 feet long is leaning against the wall of the house. Draw a picture. Always draw a picture. So my house is going to be here. My ladder is going to be leaning up against the house. And that ladder is 25 feet long, so I'll just do 25. I might actually put that on the inside. You'll see why in a second. So 25 feet long. The base of the ladder is pulled away from the wall, there's a typo, at a rate of 2 feet per second. So here's the base of the ladder. It is being pulled away from the wall at a certain rate of 2 feet per second. So when I label my pictures, I like to label the actual length on the inside and then the rate of change of each of those lengths on the outside. So if I call this A, B, and C, by telling us that the base of the ladder is pulled away from the wall at a rate of 2 feet per second, they're giving us dA dt, right? This is changing at a rate of 2 feet per second. Just kind of, they don't say it, but something that you'll get used to just knowing is, what is dC dt? What is the rate of change of the length of the ladder? 0, right? dC dt, anytime you have a constant length there, dC dt in this case is going to be 0. And the question is, how fast is the top of the ladder moving down the wall? So they're looking for how fast this is moving down the wall. So they're looking for dB dt. And the speed, obviously, the speed actually changes. It's moving faster at certain points, depending on if it's just started moving down the wall or if it's like in the thick of moving down the wall or right at the very end. So that rate of change is going to not be a constant number. Like this one is always 2. This one's going to change depending on where on the wall we are. So specifically, how fast is this going to be when its base is 7 feet from the wall? So specifically when A equals 7. So what formula could we use and then derive? What formula is going to involve these 3 variables? Pythagorean theorem. So a squared plus b squared equals c squared. And we're going to derive this. The derivative of a squared is 2a dA dt. B squared is 2b dB dt. And c squared is 2c dC dt. And then we're just going to plug in what we know. And right now, we have 2 unknowns. The thing that we're obviously being asked for, but we also don't know B, hasn't been given to us, but we easily can figure B out. Liam? Right, 7 squared plus what squared is 25 squared. If you know your Pythagorean triples, you know that that is... Any gut feelings? What'd you say? Nope. Nope. 24. 7, 24, 25 is a Pythagorean triple. If you don't know it, it's not going to hurt you to do the Pythagorean theorem, but B is 24. So, again, just like yesterday, now we just plug in what we know. 2 times 7 times 2 plus 2 times 24 times x, well, I'll leave it a dB dt, equals 2 times 25 times 0. So this whole side will cancel. This is 14 times 2 is 28, so I'll subtract 28 from both sides. So I get 48 dB dt equals negative 28. divide by 48. So dB dt equals, oh boy, divisible by 4. So negative 7 over 12. And the units would be feet per second. It's a rate. The one kind of trick about this, and you have to read carefully, especially in a multiple choice question, because you'd have an option of negative 7/12 feet per second or 7/12 feet per second. And you have to pay attention to the wording of the question. How fast is the top of the ladder moving down the wall? What would you say, negative 7/12 or 7/12? Yes. You'd say 7/12 here because they've already hit the negative part by saying how fast is it moving down. So it is moving, if you said moving down the wall at negative 7/12, there's a double negative there and it's kind of moving back up. If they just said how fast is the ladder moving, then I would go with the negative. But because they've already said down the wall, you'd go with the positive 7/12 feet per second. 7/12 feet per second. Any questions on that? Okay. B, find the rate at which the area of the triangle formed is changing when the base of the ladder is 7 feet from the wall. So I kept everything at the same moment. So by keeping the base of the ladder 7 feet away, I keep my B as being 24. And I actually now know that at that moment, dB dt is negative 7/12. So I have all of that. It's just a different question now. At what rate is the area changing? So we need to use the area formula of a triangle. So area equals 1/2 the base is A, yes, lowercase a, times the height is B in this case. Does that make sense? I'm not using B as base and H as height simply because I've kind of already got that B situation going on. I don't want to confuse things. So now this is what I derive. So we have dA dt. But on the right-hand side of this, I need what? Product rule. So first, 1/2 A times derivative of the second, dB dt, plus the second, B, times the derivative of the first, which will be 1/2, which I'm going to put out in front, dA dt. Plug in what we know, and we know pretty much everything here. So we've got 1/2 of A, so 1/2 of 7. dB dt was negative 7/12 plus 1/2 B, 24. dA dt 2. So you're not going to have a calculator. You're going to have to get crafty about simplifying things before you multiply to avoid your numbers from getting humongous. Okay? Of course, you can always simplify at the end, but your numbers might be astronomical by then, and you'll be like, how am I supposed to do this without a calculator? The reality is a lot of times you have to look for opportunities to simplify things prior. So this is negative 49 over 24 plus 24. And if I wanted to, couple things I could do here. I could change this to negative 2 and 1/24. You follow that? I think that's easier than getting a common denominator in this sense. 24 goes into 49 twice with 1 left over. So that's negative 2 and 1/24 plus 24. So essentially, 24 minus 2 brings me back to 22. Minus 1/24 brings me to say it again, Liam? Yes. 21 and 23/24. Subtracting the 2 gets you back to 22, and then subtract 1/24 from that. So pretty close to 22. And this is our area. This is the rate of change of our area. So area is units squared, so feet squared, but then it's with respect to time, so it's a rate, so it's per second. So at that moment, the area is increasing at that rate. Now, one thing I will say about this, if this had been the original question, you would have also have been missing dB dt. So you would have had to have thought back, like, how can I find dB dt? I'm missing too much, and you'd have to go back and think of another formula that might help you find that. Okay? The way I did this is I obviously set it up slowly, but if you feel like you're missing too much, there's got to be, maybe it's a completely other formula, like the Pythagorean theorem, that you have to go back and derive to find some missing pieces. Okie doke? Any questions? And then the last one, find the rate at which the angle between the ladder and the wall. So the ladder and the wall angle is right here. That's your theta. You want the rate at which the angle between the ladder and the wall of the house is changing at this moment as well. So what formula could you use here? So many options. This is going, Liam, what's your guess? Right. Yep. You could do tangent. You could do a sine, cosine, or tangent. I will say this. If you have the choice, can anyone see what might already be the easiest option? Since we can use any of the three. Just as far as using easier numbers. Sine, opposite, and hypotenuse. If we can avoid that fraction, that's good. Anytime you can use a constant, something that's got a rate of 0, that's a bonus. Anytime zeros are involved. So I'll use the sine of theta equals A over C. And I'm going to derive this. So the derivative of sine is cosine theta times d theta dt equals quotient rule here, bottom. Now, well, we can do the quotient rule. You could, anytime something's a constant, though, you could also just plug in, like, the number, a over 25. Do you follow that? I'll do the quotient rule, but bottom times derivative of the top, dA dt. Bottom times derivative of the top minus the top times dc dt, the derivative of the bottom, all over bottom squared. Okay, plug in what we know. So we have cosine, we don't know theta, we don't know d theta dt. We know c is 25, we know dA dt is 2, minus a is 7, dc dt is 0, all over 25 squared. So I'm obviously showing absolutely everything, but that 0 is going to cancel, and here's what I'm talking about. I'm not going to square 25. I'm going to let this 25 and one of these 25s cancel. So that would equal just 2 over 25. Now, obviously we're missing two pieces of information. Yes? So which one of these can we find? First. Well, we have to find it first. Go ahead, Liam. You just own the class today. Go ahead. Right. You can't find d theta dt without knowing the angle first. So at the moment when this is 7 and this is 24 and this is 25, we have to find the angle. So again, here we can use sine, cosine, or tangent. Really doesn't matter. I'll do the sine again. The sine of the angle at this moment is opposite 7 over hypotenuse 25. Now this is definitely a calculator question, and there will be a calculator section to this test. Like here? No, because that's not a constant. You can't plug in some, like that angle is going to be changing as the ladder slides down the wall. So in the beginning, if I go over here, I said we can plug in a C value. We could have plugged in 25, only because 25 is the ladder length, and that's literally the only thing that's not changing. So I can do that, and I could have said that the derivative of sine is cosine, theta, d theta, dt, and then this just would have been 1 over 25 dA dt, which is what we have, because dA dt was just 2, and 2 over 25 would give us the 2 over 25 that we have anyway, even though we did the quotient rule. So if you plug in anything in the beginning, it has to be, I just thought of something. We don't need a calculator yet. It can only be a constant. Anything that's changing, you can't plug in at the beginning. So now that we're here, I don't need this. Never mind that. I don't even need to know what the angle is, because I know what the entire cosine is. Liam, go ahead. Right. I'm not going to figure out what theta is as an intermediate step. I just know what the cosine of theta is at this moment. It's adjacent over hypotenuse, 24 over 25. So any of these plugins that I'm now doing, Josh, kind of to piggyback on what we were just talking about, is all happening after I've derived. The only number that can be plugged in prior to deriving is something that we know has a constant length. So 24 over 25 times d theta dt equals 2 over 25, and then we just multiply by the reciprocal, 25 over 24, to get rid of that, and d theta dt is just going to be 1/12. And I don't really know if this is in degrees or radians, because it doesn't say. I'd have to look back and see where I got this from. I think it should have to indicate somehow. 1/12 of a degree per second, or 1/12 of a radian? What makes more sense? What's bigger, you said? 1/12 of a radian. 2 feet per second is pretty fast. Really slow, it does. But 1/12 of a radian. One 1/12 I have to multiply by 180 over pi. That's 1/12 of a radian is about just under 5 degrees. Okay, well, anyway, I think you're right, it does make more sense. So let's put a radian per second. It should say. All right. So, how are we? I think the silence is a good thing. All right. An airplane is flying at an altitude of 5 miles. So here's a person on the ground. The altitude the airplane is flying is 5 miles up. So that's 5 miles, and we've got an airplane. Oh boy. What's Mrs. Rahill's airplane going to look like? No, Liam. It's an airplane. All right. It passes directly over a radar antenna. Yep, it is. Passes directly over them, so it's going this way. When the plane is 10 miles away, so let's say when the plane is over here. So this is 5, this is 10. The radar detects that the distance is changing at a rate of 240 miles per hour. So I'm going to go A equals, B equals, C equals. So the radar detects that the distance is changing at a rate of 240 miles per hour. So what is that? It's a rate. Is it dAdt, dBdt, or dCdt? Let's take a vote. Read it again. And actually, maybe looking for the question to see what they're looking for might also help you sift through what is what here. Okay, so get ready to vote. Raise your hand if you think dAdt is 240. Raise your hand if you think dBdt is 240. Raise your hand if you think dCdt is 240. Okay. Raise your hand if you've given up and you don't know. That's terrible. Don't do that. It is dCdt. The distance, okay? When the plane is 10 miles away, that's the distance between the radar and the plane. The distance is changing at a rate. They're asking for the speed of the plane, which is definitely this. Yes? So that's why I had you look at that as well to help you somewhat. We're looking for dAdt. That's the big question mark. dCdt, the distance that's between the radar and the plane, is growing at a rate of 240 miles per hour. So what formula are we going to derive here? Pythagorean theorem. So a squared plus b squared equals c squared. 2a dAdt plus 2b dBdt equals 2c dCdt. And at the moment that this is 10, we're still missing a couple things. We don't have an a value and we don't have dBdt. So before we jump into this, how can we find? Kyle, can you tell me what one of those equals? Okay, so a squared plus 5 squared equals 10 squared. So a squared plus 25 equals 100. So a squared equals 75, and a is going to equal root 75. If you want, that's 5 root 3. And what is dBdt? Nathan Z. What is the rate at which the altitude? Correct. That is a constant. dBdt equals 0. So the only thing we could have put in there prior to deriving could have been the 5 for B, because that is absolutely remaining constant. As this plane is flying, this leg is increasing and the hypotenuse is increasing. Yes, if you can kind of visualize the plane here versus the plane here versus the plane here, this leg and this right angle is remaining a constant. So if we had wanted to plug anything in before driving, that would be all we could do is the B. But you don't have to. So 2, sometimes it makes the driving much easier if you plug in early on. It's not really a big deal here. So 2 times 5 root 3 times dAdt plus 2 times 5 times 0 equals 2 times 10 times 240. So that's a wash. And then I'm just going to divide both sides by 10 root 3. So dA dt equals, your 10s are going to cancel, so 480 over root 3. You may see rationalization more here than previously. So 48 divided by 3, doing some mental math here. What's 48 divided by 3? 16, so that's 160 root 3 miles per hour. That's already a rate. Just out of curiosity, 160 root 3, 277. That's how fast the plane is going. Is that realistic? Not? What are you talking about? Don't they go 400 sometimes? Oh. Maybe he's preparing for a landing. Okay?
But then the altitude would be changing.
I know. I was thinking that, Connor. The altitude would be... What were you saying, Adam? I used to always go to your brother for these kind of things. All right. So we get the idea? Last one here. A construction worker pulls a 5-meter plank up the side of a building by means of a rope. So there's a building in my mind. There is a plank attached to a rope. He's got this rope, and he's got this plank, and he's pulling it up. Yes? There's my plank. The opposite end of the plank is dragging along the ground. Great, there's our right triangle. The worker is pulling up on the rope at a rate of 0.15 meters per second. So let's just immediately go A, B, C. I'm going to keep the sizes on the inside and the rates on the outside. That just helps me keep it organized. So if the worker is pulling up on the rope at a rate of 0.15 meters per second, is that dA dt, dB dt, or dC dt? Take a minute because we have time to try to see what things you can label here. A, B, C, dA dt, dB dt, dC dt, based on what's given. Okay, I'm just going to go through the numbers and pick on a few of you. A construction worker pulls a 5-meter plank. What did you label 5, Ellie? C is 5, correct. C equals 5. The opposite end of the plank dragging the worker is pulling up on the rope. What did you label 0.15, Haley? dA dt. Did anyone label something different? 0.15? Raise your hand if you also labeled dA dt 15. 0.15. Good. That's correct. dA dt equals 0.15. Right? You're pulling up on the rope, so this point is moving up at that speed, which means that's the length increasing at that speed. Good. How fast is the end of the plank sliding on the ground when it is 2.5 meters from the wall of the building? What did you label 2.5, Adam? B. 2.5 meters from the wall of the building. Perfect. Okay. So we're still missing A. We're still missing dC dt. And we're still missing dB dt. Which one of those, Michelle, could you tell me? Perfect. The length of the plank is not changing. And Winter? Okay, so now we have, so which one can we figure out first? A or dB dt? Those are the only two things we're missing. A. We can find A using the Pythagorean theorem. So A squared plus 2.5 squared equals C squared. So we have 25. We're going to subtract. Anybody know? You should. What's 25 squared? 625. So 2.5 squared should be 6.25. Good. So A squared is 25 minus 6 puts us at 19, minus another 0.25 puts us at 18.75. Square root, square root. So A equals square root of 18.75. Probably definitely calculator one. I'm scared. And so we can derive A squared plus B squared equals C squared. 2A dA dt plus 2B dB dt equals 2C dC dt. So the only way we might get away with not using a calculator is if we made what could we make 18.75? 18 3/4. 4 times 18, 20, 40, 60, 80, 72, 75 fourths. That's a beautiful number to take a square root of, isn't it? Yes? So for A, the square root of 75 fourths, by the way, is the square root of 75 over the square root of 4, which is 5 root 3 over 2. dA dt is 0.15. I'm going with 15 100ths. I'm going to really work hard not to use a calculator. 2 times B is 2.5. I'm going to make that 5 halves. dB dt is what we're looking for. I will. I'm just showing my work. C is 5, dC dt is 0. Okay, so some beautiful stuff is about to happen. Our 2's cancel. Our 2's cancel. The 5 and the 100 become 1 and 20. 15 20ths is 3/4. So I'll do 3 root 3 over 4 plus 5 dB dt equals 0. Subtract my fraction over. And dividing by 5 is going to make dB over dt equal to negative 3 root 3 over, dividing by 5 is the same as multiplying by 1/5, so over 20. Now, things to look for. Should dB dt be negative? If this is pulling up, this is pulling in and shrinking. So yes, the negative makes sense. Do you follow? I kind of enjoy it. I don't know if you do, but it'll give you some, it's hard to kind of know how you feel about it too.